Okay, so we've got another unknown sample. We want to determine its molecular formula. We have carbon, hydrogen, and oxygen. We start with 40% by mass carbon in this sample, 6.71% hydrogen, and 53.29% oxygen. By assuming 100 grams, this is 40 grams, 6.71 grams, and 53.29 grams of oxygen. I'm moving more quickly than I have in previous examples, but if you look at example 1, I move much more uh, uh, slowly through the problem. So here I use the molar mass of carbon to convert from grams to moles, and 16 grams of oxygen, 1 mole of oxygen. Now I should have moles of each element in this sample. 40 divided by 12.011 gives me 3.33 moles of carbon. 6.71 divided by 1.01 gives me 6.644 moles of hydrogen. And 53.29 divided by 16 gives me 3.33 moles of oxygen. Now you notice I can't really find the smallest molar amount because 3.33 is equal to 3.33. But the issue is here that I rounded. I rounded to 2 decimal places, which was a little too much. That's one of the dangers of rounding. We don't want to round too much, especially our intermediate values. So if I actually take it out 2 more decimal places, this would be 3.3306. And for carbon divided by 12.011, this would be 3.3303. Now, can we determine the smallest mole amount? Absolutely. That would be this one. So I divide both by, all of the mole amounts by 3.3303. Now, of course, it doesn't affect that very much. That's still equal to 1. 6.644 divided by 3.33 is equal to 1.995. Very close, again, to 2. It's always going to be very close within decimal places of some number. And it may not be a whole number, okay? But in this case, it's very close to 2. So I have my empirical formula. My empirical formula is CH2O. It's actually the empirical formula for formaldehyde. So let's see if the molecular formula is this formula, which is the empirical formula. Sometimes the molecular formula is the empirical formula, sometimes it isn't. So to find molecular formula, let's take the molecular molar mass and divide it by the empirical formula molar mass. The given molar mass of the actual molecule is 180.16 grams per mole. What's the molar mass of the empirical formula that we have right now? Well, 12 plus 16 plus 2.02 is 30.02. So if I take 180.16 and divide it by 30.02, I get 6.00. This is going to serve as a multiplier. The molecular molar mass is 6 times greater than the empirical formula molar mass that we have from our current empirical formula. That tells me that this molecule, this unknown sample, does not have this molar mass. Okay? So we take this multiplier and we multiply all the subscripts in the empirical formula by that multiplier to get our molecular formula. So if I multiply all of these by 6, what I get is C6H12O6. 6.